Hi everyone, we're going to find the critical numbers for a function by applying the first derivative test, and then we're going to find the open interval where f is increasing or decreasing. So the first thing I'm going to do is take the derivative of the function. This is a trig function. When I do that, the derivative of this is just 1/2, and derivative of cosine is negative sine of x. And to find the critical numbers, we set the derivative to 0. So we get sine of x equals 1/2. Therefore, our critical numbers are x equals pi over 6 and 5 pi over 6. Now I'm going to test the intervals. So we have our critical numbers again at x equals pi over 6 and 5 pi over 6. And also, we're restricted between x from 0 and 2 pi. So what we want to do is test from 0 to pi over 6, and then from pi over 6 to 5 pi over 6, and then from 5 pi over 6 to our 2 pi. Let me erase that. So it's going to be 2 pi. And basically what I did, our derivative was 1/2 minus sine of x. So I'm plugging in a number in between 0 and pi over 6. So if I take the midpoint of those two, I get pi over 12. We know pi over 12 equals 15 degrees. So basically I'm plugging that into my equation, and I'm getting a positive number. So that means the sign of my derivative is positive. I do the same thing here. I'm taking the midpoint of those two, and I'm going to get, you add those up, you're going to get 6 pi over 6 divided by 2, so it's pi over 2. And if you plug in that, you're going to get basically 1/2 minus sine of pi over 2, and that's going to be negative, because sine of pi over 2 is 1. So my derivative is negative. And for the last one, I'm doing the same thing. We'll take the midpoint between 5 pi over 6 and 12 pi over 6. And that gives you 17 pi over 6. And you have to divide that by 2. So it's 17 pi over 12. And so that's 17/15. So if you plug that in, you're going to get your derivative is going to be positive. So what we have is increasing on this interval, decreasing on this interval, and increasing here. So basically increasing from 0 to pi over 6, decreasing from pi over 6 to 5 pi over 6, and increasing on the third interval. So that's between 5 pi over 6 and 2 pi. Alright, now we want to find any relative maximum or min. So basically, right in here, this is increasing, so it's going up, then down, and then right back here it goes back up. So you know how sine and all that is. So we need to find the relative min and max, which would be right in here and here. So what I'm going to do is take my equation, f of x equals x over 2 plus cosine of x, and I'm going to plug in pi over 6. So you get pi over 6 divided by 2 plus cosine of pi over 6. Okay, so this is going to be pi over 12 plus square root of 3 over 2. And if you want to put this all over 12, you would have pi, and if you want this, we need to multiply this by 6. This would be 6 square root of 3. So my relative minimum is occurring at pi over 6, and then pi plus 6 square root of 3 over 12. Now we do the 5 pi over 6, and that's going to end up being 5 pi over 12 minus square root of 3 over 2, which is going to be 5 pi over 12 minus 6 square root of 3 over 12. Or you can put it all together. And so that is going to be a relative minimum based on my intervals I tested. 5 pi over 6 is my angle, and then my output is 5 pi minus 6 square root of 3 all over 12. And that's all. Thank you. Have a nice day. Bye-bye.